Here's how to explain the Bohr shift for A-level PE. So the Bohr shift occurs during exercise, and it's when this oxyhemoglobin dissociation curve shifts to the right. It happens due to an increase in one of these three things: CO2, lactic acid, or body temperature. And when those things increase, it lowers hemoglobin's affinity for oxygen. And affinity means attraction. So this means hemoglobin's attraction for oxygen goes down. And that means it now dissociates with even more of it. So it lets go of even more oxygen. So let's say this is a hemoglobin protein. If rates of dissociation increase, it means that that hemoglobin is letting go of even more oxygen than it usually would. And this is a good thing because it means that all this oxygen now is available to diffuse into the muscle. And just so you're able to interpret the graph, let's say this is the muscle here. This is how much oxygen is in the muscle. At rest, it's saying that hemoglobin would be roughly 75% saturated with oxygen at the muscle. So each hemoglobin would look like this. It'd have 3 out of the 4 oxygens still bound to it, and it would only have dissociated with one of them. Whereas if we work up to the Bohr shift line, it's now saying that that hemoglobin molecule would only be 25% saturated with oxygen. So that means it's dissociated with 3 out of the 4 oxygens. So it's increased the amount of oxygen that it's let go of. But that is good because these oxygens now are available to diffuse into the muscle. So the Bohr shift is basically just showing how there's an increase in oxygen availability to the muscles during exercise.